Hi friends, in this video we're going to talk about how to chat with LLMs in Python using Langchain. Langchain is a framework to easily build apps with LLMs. So let's see how we can use Langchain to chat with LLMs. For this demo, I'm using LM Studio to run a local LLM in my laptop that can even use integrated graphics. If you want to know how to run local LLMs in your laptop using LM Studio, I've already made a video on that. You can check it out. I will leave the link of that in the description. And in LM Studio, you have developer options where you can enable the LM Studio server, which provides an OpenAI compatible API to interact with LLMs. So that's why I've installed Langchain OpenAPI pip module, which gives this chat OpenAI module. If you want to talk with your OpenAI modules running in the cloud, you can use the OpenAI URL, API key, etc. But in my case, I'm running a local LM Studio OpenAI compatible LLM. So I'm telling the model Llama 3.23b, which I've already installed in my LM Studio. I'm giving the base URL as the server's API base, and API key is not required. So I've declared my OpenAI model here, and all I need to do is model.invoke the messages which I want to give, and that's it. The model will respond. So just by declaring a model and invoking it, you can get the response from an LLM. Now let's see the convenience you can get using Langchain. Now if you replace this chat OpenAI with this chat Anthropic, you need to do Langchain Anthropic pip install, and then you have to declare the model as chat Anthropic model, and your application remains the same. Langchain creates abstractions over these different LLM vendors. So you don't need to rewrite your application for OpenAI models, Anthropic models, or Ollama models. By the way, if you want to chat with Ollama models, you have Langchain Ollama and you declare the model as chat Ollama. Alright, we've installed Langchain, we are invoking a model. Now how did I give messages to my model? You can pass a list of messages which is like a chat history, and the messages can be of 4 types, which is the system, AI, human, and tool. Here I'm giving 2 types of messages, which is system message, and here I'm instructing the model using system message on how to respond to the queries. So the system prompt here is you're a helpful assistant that translates English to French, and then I give my human input, which is like a user asking a question to the LLM. So the human is saying I love programming, and now the output should be the French version of I love programming. So let's see the Langchain documentation about the message types. The system message type is the system prompt. The user message type is basically the user asking the question. The assistant message type is basically the AI message type, which is the response from the LLM to a question. And the tool message type is basically the response given by the tool to the LLM. So in Langchain, LLM can invoke tools and get the response from them. So tools are like API servers. So Langchain can call tools where they have some specific logic or they are some LLMs or whatever, and you can get the response from the tools in a tool message. Currently we are not covering this tool message in this video. We may cover it in our future videos, and that's it. Let's try to run our first Langchain program. So the question was I love programming, and the answer should be the French version of it. The LLM is loading and generating the response here, and once the response is given, I got the French version of I love programming. Now let's talk about a prompt template. Prompt template is simply a prompt with variables placeholders where you can inject variables into it. For example, you can have this chat prompt template class imported from Langchain core prompts, and you can give a list of messages here. The first message is static, and the second message is the messages placeholder. So if you invoke this prompt with an object, and if the object has a key called messages, the message would be pasted here. So chain.invoke messages, and here I'm giving a list of messages, which is like a simple human message in a list. So what happens here is when I invoke this prompt, this message variable would be substituted here. So that's basically a prompt template. Now let's cover chaining in Langchain. So chaining means you can have one runnable passing its result to another runnable. So I got the model here. I got the prompt template as prompt here. Now I'm creating a chain that sends the result from this prompt to the model. So prompt pipe model will inject this prompt output into model, and this is our chain. So now instead of invoking the model, I will invoke the chain. So I'm telling chain.invoke, and here since the prompt has this placeholder for messages, I will give a dictionary with the key called messages, and here I'm passing the list of messages. And again I will get the response in this AI message variable, and I'm printing it. Now let's try to save this and run it. As expected, we got the French translation. But in this example, we have used a prompt template and a chain. So we have covered prompt templates and chaining in Langchain. Now let's see how we can manage chat history. You see, by default, when you invoke a model, it will not remember your previous questions. So if you ask a question like who is Albert Einstein, and if you ask a follow-up question like when was he born, the LLM will say I don't know who you are talking about. So because the LLM doesn't know about the previous question. Well, how to mitigate that? While invoking the chain, instead of giving the list with only the current message, if you are able to give the whole question and answer sequence of the chat, the LLM will know what is the conversation till now. It's that simple. So you declare a variable called chat history, which is a simple list of messages, and for each query, append the chat history with your query and also the response you got from the LLM. And next time you ask a question, ask with the whole chat history. And that's it. Just by using this chat history list and passing the history to the LLM, you can now ask follow-up questions to your LLM. So to simulate a conversation, I have given a list of queries like who is Einstein, when did he die, what is he known for, what are his awards, and who am I talking about. So I will pass each query one after the other, and I will append the chat history with the query and the query response. Now let's see how the output would be. So the question was who is Albert Einstein, and I got a response. Again the question was when did he die, and the chatbot knows I'm talking about Einstein. In the same way, for the follow-up questions, the chatbot knows I'm talking about Albert Einstein. So this way, just by passing chat history to the LLM can get a context of what is the conversation till now. So there is chance of one issue here where your chat history is so long that it might exceed your token limit, or your LLM may distract because of your previous conversation. So there can be two strategies to tackle this. One is that you consider only latest 10, 15 or 20 messages, or else you can summarize your whole chat history into one message and then replace your chat history with that summarized history. So to consider only the last 4 messages in my chat history, I have written a function called trim messages, which will take in the chat history and provide you the trimmed chat history. And for that I am using the trim messages convenience function from Langchain core. You can even implement your own trim messages function, but I am using the Langchain core's trim messages function here. And now, before invoking the chat history, you just replace the chat history with the trimmed chat history. So I'm going to say trim messages of chat history. So now each time I'm asking a query, I'm trimming my chat history to have only some threshold number of messages. And now let's talk about another strategy, which is summarizing the whole chat history. So if your message count is more than something like 20, 30, what you can do is you can summarize your whole chat history into one message. To do the summarization, I'm actually calling an LLM. So I'm telling distill the above chat message into a single summary message, and I'm asking the model to summarize the messages. And now I'm returning only the summary message here. So now when you get a query, first summarize the messages and replace that with the chat history, and then move on with your flow. So if the number of messages exceed, you will summarize the messages, and now you will not have the token limit problem. So that's it. This is how you can talk to LLMs in Python using Langchain. Now let's cover another scenario where you can have multiple chat threads asking a single model. So suppose you have this thread called 1 and you have this thread called 2. Thread 1 and thread 2 are multiple chat conversations. So now to tackle these queries, all you can do is pass only the chat history of that particular thread. So in this case, instead of keeping the chat history as a list, I am keeping the chat history as a dictionary, and each key is the thread ID and the dictionary values are the chat history. So when I get a query, I will see the thread ID and I will retrieve only the chat history of the thread ID and then pass only that thread charts to the chain. So this way you will not mix your queries, and one model can cater multiple chat sessions. Alright, let's see what we did till now. We have used Langchain to chat with our model, but we were faced with a problem where we need to maintain chat history, and we solved that problem ourselves. Instead of managing the chat history ourselves like we did till now, there is a better alternative where you can use Langgraph to manage your chat history. So Langgraph is a very awesome framework where you can split workflows into nodes, and each node can be just a function or a function which calls an LLM, Langgraph can store the whole state of this graph as the application state. And also Langgraph gives us the convenience of managing multiple threads and persistence of chat history. So let's try to solve this problem using Langgraph. So to use Langgraph, you have to do pip install Langgraph, and we have created a prompt template, we have created a model, we have created the chain. Now in Langgraph, we are declaring the state, which is the Langgraph state. And our state is basically the chat history. We are storing that in messages, and the annotated list with add messages means any change you give would be appended. You can't replace the state. And if you want to replace the state, there is another way, but we won't discuss this now. Just think that any change you give to the state would be appended. I'm using the graph builder, and it's a state graph. That means the graph will have its state. And remember, we have nodes in this Langgraph, and each node is actually function. So I am creating this node called call model, and what it does is that it accesses the state, gets the whole chat history using this state.messages, and invokes the chain. The result of the chain invocation is obviously the AI response, and we are giving the state change as messages and AI response. So since it's a append only state, when you pass the state change as messages with only the AI message, instead of replacing the whole messages, the AI message would be appended to the state. It's like Redux. So I have defined my node, and I have added the node of the chatbot, which is the call model function, and I'm declaring that this is the entry point to the graph, and I have compiled the graph. So when you compile the graph, you'll get this application variable which you can invoke. But during compilation, I am telling checkpointer is equal to in-memory saver, and this is where the magic happens. Since we are giving a checkpointer, the state of the graph would be persisted, and next time the graph is invoked, it will use the recent state and then invoke it. So this way, whenever you invoke the graph, the previous chat history would be used and the graph would be invoked. Now my graph is ready, and I can call this graph using app.invoke, and the input is messages, and this messages would be used in this prompt placeholder where messages placeholder is used. And Langgraph also solved this chat threads problem by giving a configuration variable, and here configuration is a dictionary with configurable thread id equal to thread id. So instead of you manually segregating the chat history based upon chat threads, Langgraph uses the convenient chat thread feature. So this way, using this checkpointer, I'm managing the chat history, and using this thread id, I'm managing multiple chat sessions. So just by using this in-memory saver and configuration, I'm not writing any code to manage the chat history and chat threads. So if you use Langgraph instead of Langchain, you will get these convenience functions. Alright, let's try to run this demo. You can see we're getting answers as expected. So that's it, guys. This is how you can use Langchain to interact with LLMs in your Python scripts. The whole content of this video is present in this blog post, so please be sure to check out the link of this blog post in the description of this video. I have also given some useful references to the official documentation. Also, please check out the Langchain documentation, which is amazing. Please ask questions or post your valuable feedback in the comment section. Hope you like this video, guys. Thank you for watching. Peace.